This is the final calculation we need to be able to do in this energy changes subtopic. We're going to need you to learn this formula. It's not given on the data sheet, and one of the things you're going to need to know is what these letters all stand for. Quite often you'll get a question that asks you to calculate the energy of a reaction, and they'll also give you the mass of something in the question. We'll do an example and it will make a lot more sense. But Q is the symbol that stands for energy and is measured in kilojoules. N we've seen previously, that is the amount of substance. Okay, so it's measured in moles. And delta H, or R for the reaction, enthalpy change, that is measured in kilojoules per mole. So it's very important whenever we're using a value that is for enthalpy change, it must be for 1 mole of substance. And you can see that in the units, it's kilojoules per mole. And I'll be emphasizing that because that's a real big component of getting your questions correct, is making sure your enthalpy change is for 1 mole of substance. I'll just break down what this means a little bit more but quickly. So the triangle symbol refers to change. The R is a symbol there which means reaction. So you can actually just ignore that because obviously every chemical is going to be a reaction, chemical reaction. H we've seen a few times now. It is the enthalpy, so it's the heat content of the reaction. Now this little degree symbol, what that is indicating is that the chemical reaction has been carried out under standard conditions. Now standard conditions is where your lab has been temperature controlled to be at 25 degrees. So obviously our lab gets a lot hotter and colder and changes, so we wouldn't be able to use the standard conditions on our chemicals. But if you're doing this in a professional laboratory, they will have it thermostatically controlled so that the conditions are 25 degrees. They'll also have the pressure of the room at 1 atmosphere, but then every where on Earth that is at sea level is experiencing 1 atmosphere. The only time you don't have 1 atmosphere of pressure is if you're on the very top of a mountain, or if you're in the very, very depths of a deep, deep gully, then the pressure will be lower if you're up on a mountain, and obviously you'll be experiencing a lot more pressure if you're deep, deep down in a gully. But I'm not talking, just a few hundred meters. I'm talking hundreds of meters to get a pressure change. So we really can just ignore, but I wanted to point out so you were aware what this little degree symbol means. Moving along, so to use this calculation, the question will often ask you to calculate the energy, so that is your Q value here, and that is heat energy. We are going to need the amount of substance. Often you're going to be required to do a preliminary calculation, and you'll need to calculate that, which we've been doing. It's simply taking the mass divided by the molar mass. And once you've got the amount of substance, that's when you get to multiply it by the enthalpy change for the reaction, and that's where you've got your 1 mole of substance. So this is the equation. We've seen this a few times. It is on the data sheet, so you don't have to memorize it. But if they don't give you the amount, and 99% of the time they don't, they give you mass, you're going to need to take your mass value first and divide it by the molar mass to get this N value. So there'll often be 2 steps in the calculation. Let's have a go and do one. So this question is asking us to calculate the energy, so that is the Q value, when 23 grams of ethanol is burned. So like I said, step 1 is convert your mass, that's that 23.0 grams, that's a mass value, to amount. So mass over molar mass. So there we go. The molar mass is always provided as well. You won't need to calculate that. You just need to find it in the question. So 23 over 46. And what we've got is 0.5 moles of ethanol. Then you're into step 2. So the calculating the energy, you'll need to recall this equation. Q equals the amount, which we just calculated to be 0.5, times the enthalpy change. Now, this won't be clear for a while yet, but the equation they gave us is 1 mole of ethanol up here. And so this energy is for 1 mole of ethanol, which is why we can just go straight in and use that value. We don't have to manipulate it at all. So in the calculator, 0.5 times negative 1235 kilojoules per mole. Remember, the negative here is telling us that it is an exothermic reaction. And what I'm going to do is Q is simply energy. So it does not need to have that negative value, and that's why it disappears when I tidy my answer up. But I do replace having the negative, meaning exothermic, with the words here, energy released. Okay, so for a Q value, I don't want to see a plus or a minus. I want to see the words energy released. If it's endothermic, I would see the words energy absorbed. And the reason we've got this second line is I've tidied up what was 4 significant figures down to 3, and that there is your energy released when you burn 23 grams of ethanol. Now the question can be extended. The next part to this question, they're asking, calculate the energy released when 108 grams of water is produced. So here we can see you've got 3 waters being produced, and that's the energy for 3 waters produced. So we are going to have to change and manipulate that for the delta H. But the first step is to calculate the amount of here we go, sorry, don't know what happened there. So what we need to do is first up calculate the amount of water. So you've got 108 grams of water, and we are going to divide it by its molar mass. So we've got 6 moles of water. Now, as I was saying, we have got 3 moles of water being produced, and the energy that correlates with those 3 moles is this number here. Now, the energy applies to the whole equation. So yes, it stands for 1 mole of ethanol reacts with 3 moles of oxygen, and it produces 2 carbon dioxides and 3 waters, and that's the total energy released. Now, if you manipulate this equation so you get it per 1 water, then that would be a third 1 oxygen, a third of 2, and then 1 water. So the energy you get if you were just making 1 water, and yes, you'd have a third of everything else, would be only a third of the energy. So this is where you've got to keep the law of proportions in the back of your mind, because delta H is the energy, but considering just 1 mole of water. But yes, it would stand for, yes, you have these other components that are reacting to produce that. Okay, so it's a bit of a tricky concept to get your head around, but once you've got it, it makes a lot more sense. So we're going to be using, for the enthalpy value, this negative 411, because that's per water molecule. And you can see I divided the whole equation by 3 to get that. Okay, so that is your final step, is to calculate the energy. So we've got the 6 moles of water. We've got the enthalpy for 1 mole. So 6 times that number gives us, oh, much bigger than that. That's definitely not meant to be there. Sorry guys, there's a little typo. It's this value here, this 2,470. Notice I took the negative symbol away and replaced it with the words energy released, because Q does not have a plus or minus symbol. And then I tidied it up to 3 sig fig by shifting the decimal place to between the two, so it's 2.47 times 10 to the power of 3. If you're not comfortable converting it to 3 sig fig, leave it as your whole number there, because I have seen that being accepted, so you should be okay. Finally, we've got this third part to the question, which is to calculate the energy released when 8 grams of oxygen is consumed. Now notice we're still using the same equation. This equation applies for the whole of the, both reactants producing both products. So we're going to start, as we've done for the last two parts, calculating the amount, which is to take the mass over the molar mass, and that gets us 0.25 moles. As I did for water, I am seeing that 3 moles of oxygen is reacting with the ethanol to produce this amount of energy. But if you only had 1 mole of oxygen, and that means a third ethanol, then you'd only get a third of that energy. Okay, so you do need to convert your delta H so it's per 1 mole of whatever the substance is that you're reacting or looking at. So now we are into the final step, which is take the amount of substance, 0.25, take the enthalpy, which is for 1 mole, in this instance oxygen, do the multiplication, and you get 102.9. Round it to 3 sig fig, so nice and straightforward this time, and take away the negative symbol and replace it with the words energy released, and the job is done. Okay, they're not easy. You need lots of practice, so that is your task for the rest of this period, as well as our lesson on Monday. Okay, I want you to practice the questions on page 114 right through to page 117. And you're done. You've finished the course.